Did you know that water behaves quite weirdly? And this weirdness of water is the reason you are alive. The reason I am alive. In fact, all life on earth exists because water behaves weirdly. Let us now try and understand this anomalous behavior of water. Okay? So, first of all, let us look at what normal objects do when you increase the temperature. You know that when temperature increases, volume increases. In fact, we know that the final volume of an object is equal to the original volume V0 into 1 plus gamma times delta T. What is gamma? The coefficient of volume expansion. And what about density? Density is mass by volume. So if volume increases, density will decrease because mass is the same. So when temperature increases, density decreases. And this relationship tells us that the final density is initial density, rho naught into 1 minus gamma delta T. Notice that there is a minus here which is telling us that density decreases as the temperature increases, and the plus there tells us that the volume increases as the temperature increases. The best way to understand this is by drawing a graph. So here is the temperature on the x-axis, this is the volume. So if I start initially with a volume like this, as the temperature increases, the volume will also increase. So the graph looks like this, almost a straight line. And suppose this was a steel rod. At about 3000 degrees Celsius, what is going to happen? It is going to melt. When it melts, the volume will increase quite a lot. And then as the temperature continues to increase, volume keeps on increasing. But overall, you can see that the volume keeps increasing as the temperature increases. In fact, not just for steel, most objects behave like this. So this is true for almost all materials. Why am I saying almost? Because water is very weird. It behaves differently. Why differently? We are going to understand that by looking at a similar graph for water. So let us start with ice. So if I start with ice, let us say the volume was like this. As the temperature increases, what is going to happen? Well, it doesn't seem very different, right? Volume increases. So far, it behaves exactly like all other materials, except at 0 degrees Celsius, something else starts happening. Ice starts to melt. But when ice melts, its volume decreases. Liquid water is denser. Its volume is lesser. Volume is lesser means density is more. So liquid water is denser than ice. So notice this was going up, but that has come down. Whereas here, when it melts, it goes up. Here, when it melts, it goes down. But not just that. From 0 degrees Celsius, you have liquid water, but as I increase the temperature from 0 to 4, water's volume keeps decreasing. Notice it decreases first and then it increases. This portion looks like everything else, but this portion, 0 to 4 degrees Celsius, at 0, first of all, the volume decreases, and then from 0 to 4 degrees, the volume decreases further. So 4 degrees Celsius, that's a very interesting point. At that point, water has the lowest volume and the highest density. Okay, lowest volume and the highest density. Notice that from here to there, the graph is going down, whereas for everything else, it is just going up. Even for water, beyond 4 degrees, it is going up. Okay, and if you look at this portion, again, it is going up. This 0 to 4 is where there are lots of weirdness, lot of weird stuff that is happening. And it turns out that this weirdness is super important. Let us focus on this graph alone and try to understand this. First thing, notice, ice has more volume than liquid water. What does that mean? Ice has less density than liquid water. So, ice floats on water. That's why ice cubes float on a glass of water. You have icebergs, right? Glaciers floating on water. This is why you have Titanic, right? You had all the Titanic movie because of this. Okay, now that may sound like a little bit of curiosity, but how is that related to life? Let us look at that more carefully, okay? So you can look at any water body. This could be the sea, this could be a lake, okay? Now, the temperature varies like this, 10 degrees Celsius, 9 degrees Celsius, 6 degrees Celsius. why is this colder? Why is that warmer? Think. How does water in a lake get heated? Is the heat coming from the bottom? Well, you could, right? If there was some volcanic eruption or something, yeah, it could come from the bottom. But that's not how it usually happens. How does it happen? Sun gives us the heat, right? So either sun rays come and directly fall at the top, or they heat up the land and then that heats up the air. That air then heats up the top layer. So the top layer gets heated up first, then the next layer, next layer, next layer, and so on. Okay? So now let's think. Suppose it is getting cooler. Let's look at water getting colder. Suppose 6 degree water here, right? Suppose there was originally 10 degree and it cools down to 6 degrees Celsius. Why would that happen? Because let's say the air got quite cold and so some of this heat was released. Remember, the top layer is the one that is interacting with the air above. So any heat exchange is going to happen from the top layer. So the top layer, let's say it becomes colder. If it becomes colder, what will happen? From 10 degrees, if it came to 6 degrees, that means the volume is reducing. Well, if you go that way, the volume is increasing. But if I go down, right, it reduce, volume is reducing. But if volume reduces, density will increase. So 6 degree has more density than 10 degrees. So it will sink. Then 7 degrees will have little more density than 10, right? So it is going to go down, but it will be less dense than 6. So it will stay at the top, right? And then 8 will be little above 9. No, this is the normal distribution for most materials, right? You know that suppose you had a liquid and the top layer, basically some other liquid, let's say something like mercury, and you lower the temperature at the top, it becomes solid. What's going to happen? It will basically sink because it will be denser. So that's what is happening. Okay, so as it starts to become lower temperature, it will sink. Doesn't seem very different, but wait. Suppose I reduce the temperature further, you're going to get the same kind of distribution, 8, 7, 6, 5, 4. But at 4, something else starts to happen. Notice that 4 is when the water has the highest density. So now, suppose I lower the temperature even more, right? Suppose I made this 3 degrees Celsius. I basically pulled out some more heat from the top layer. From the top layer is where you can lose heat. Suppose this becomes 3 degrees Celsius. Will it go all the way and go below 4 degrees Celsius? Think about it. 3 degrees Celsius. Well, below 4, the volume, what is happening to the volume? As I keep going down, the volume is increasing, which means density is decreasing. So 3 degrees Celsius water will be lower density than 4 degree. So 4 goes to the bottom, 3 will not go below it. So let me move this and show you what happens when I reduce the temperature below 4 degrees. The 3 degree water will be above 4 degrees. Here notice, 4 degrees below 5 degrees, whereas here 3 degrees above 4 degrees. Similarly, 2.5 will be above 3, 2 will be above this, 1 degree will be above 2. So it's completely reversed. Yeah, again, it sounds okay, but what is the use? Remember in very, very terrible winters, and Earth has gone through lots of glacial periods where it is like really massive winters. So it won't stop at one. More and more heat will keep escaping from the top layer. So let us say that this basically becomes 0, right? It will become, let's say, ice. Then what will happen? This will become ice. Will it sink down? No, because ice has more volume than water, so less density than water, it will float. Ice will float. So this remains ice there, and then what happens? Once it has become ice, it cannot take, ice is a very bad conductor of heat. So it's not going to take heat from this and pass it on to the air above it. The air above it can get very cold. Maybe this ice will go from 0 degrees Celsius to -1, -2, even -10. It will become like rock solid ice. But this heat will continue to remain because ice is a bad conductor of heat. It's not going to take the heat from here and pass it on. And because you had the top layer freezing first and all these are protected, this entire water inside, only the top layer becomes ice. The rest of the liquid water is safe. So fish can basically happily move around, plants can continue to be there. So throughout winter, this water remains water. And at what temperature? A lot of it at the bottom will be about 4 degrees. And here you have 1 degree, right? So you have this variation. But so you can have life continuing here. Only the top layer has frozen. Just imagine what would have happened if ice had more density. Well, then the moment it became ice, it would have sunk. Solid generally have more density than the liquid version. So it would have sunk. Not for ice, okay? I'm saying in general, for some other material, it would have sunk. And then the next layer would have become the top layer. It would have again frozen, then sunk. So layer by layer by layer, you would have had the bottom layers all getting frozen. So the entire lake would have frozen. All the fish would have died. Everything else inside would have died. So there would have been no life in this lake or the sea. So for aquatic life, right? Life in water looks like the weirdness of water is super important. Now you might think, okay, for life that is in water, maybe animals that are living in water, this is important. Maybe not so important for us, but wait a minute. How did you come up? Think about it. We all evolved from fish. We all evolved from life in the sea. So if the sea was frozen, life would have gone completely extinct, which means you would not even be here. All life on earth depends on this weird behavior of water. If water didn't have this weird behavior, we wouldn't exist. So we can thank the weirdness of water for our being here. If you like this video, please hit the subscribe button below. And if you have some comments or if you have doubts in physics or math, please write it in the comment section. I will take one of your questions and make my next video. See you all in the next video soon.